So, question 3 of the International C34 paper. June 2015, Edexcel. Or Pearson's, take your pick, same thing. Now, first part, most of you done fine. It's just using the product rule and rearranging and getting the exact coordinate of A. Some people haven't given me the exact coordinate of A, but that's which is what we've been asked for. A lot of people missing out on the 2 marks on part B, but most then are getting part C. But let's go through the whole thing. Part A, product rule. Let's use the notation we're given, so F stroke X. You can write the things out in the U's and the V's out separately, but really we've got U there and V there, so it's U times by dV by dx, which is EX, and du by dx, which is 2, times by that, which is e to the x. Now rearranging that just becomes 2x minus 3 e to the x, because we've got 2 of them here. We've got 2 of them here, and we've got, so that the minus 5 and the 2 makes minus 3. Nice and easy. So then we need to, because it's talking about a minimum turning point, this point here basically, we can just say that F stroke X is 0 for the minimum. So that gives us 2x minus 3 e to the x is equal to 0. So we can see that the 2x minus 3 bit is a bit that's actually going to determine this, because that's never 0 for any real numbers. It's got an asymptote there, but it's not actually ever equal to 0. So we've got 2x equals to 3, x equals 3 over 2. Now it wants exact, so we'll give exact. We work out f3 over 2, which is 2 times 3 over 2 minus 5 times e to the 3 over 2. 2 times 3 over 2 is equal to 3. It's minus 5, so that's minus 2 e to the 3 over 2. So let's write that coordinate. I can write it here. That's 3 over 2 minus 2 e to the 3 over 2. Okay, so many correct answers to that, which is good. So the next bit was the bit where where marks were lost. Most of it was here. There were a few lost marks here as well. Sometimes we're not giving exact answers, just not answering the question. So, but most of you are okay with that. And then it says, given in part B, given that the equation, where is it? Fx equals k has exactly 2 roots. Doesn't say it's got 1. Doesn't say it's got. Doesn't say it's got. It can have none at all. It's got exactly 2 roots, and 1 won't do. Okay, so now, if we look at this, I've just put this on here, the line y equals k here. Okay, now, looking at that line, okay, looking at that line, you can see where I placed it at the moment, the value of k there. If it were k below minus 2 e to the 3 to 2, there'd be no real roots. But then, if I were to place it above, okay, so if I were to place it above at this point, say, then there's 2 real roots there. Now, so what values are there 2? At the moment, there's 1. Oh no, there's 2 here, 2. But there's only 1 root here. So if x is equal to 0, because it can't at that point, because it can't be there would only be one real root. So we can clearly see that x has got to be greater than 0. Can't be equal to 0. Okay, but it can be some number. Sorry, it's the wrong way around. X has got to be less than 0. Colours here. So x has got to be less than 0. Oh. Okay, we'll try again. So x has got to be less than 0. Clearly. Okay, because if it's equal to 0, there's only one root, but less than 0, even if it's a little bit less, we can't see the root there, but there will be one later on. Okay, now if I place it further downwards, still got two real roots here. I've still got two real roots. My value of k here is approaching the minimum here at minus 2e to the 3 over 2. Now, there it's still got 2. Just below that, it's still got 2. But of course, once you get it to be equal to that, there's only one root. If it were bang on e to the minus 3 over 2, then there would be one real root. And of course, now there's no real roots. Now it says exactly 2, so it can't have 1. Then it needs to be greater than this number here. Right, now that's part B. Part C was just a standard thing. It has asked for the graph of y equals mod fx. And basically, for that graph, we will have, I'll put the axes up now. This part of the graph is actually obviously not changed by the modulus sign, so that's still doing that. But the rest of this part here, this part, all this part is going to be reflected. So it's going to do there with a maximum now and an asymptote there. And that's it, but don't forget, it says indicate clearly on your sketch your coordinates of the point at which a curve crosses or meets the x-axis. Crosses or meets. Right, so it meets the x-axis at this point. Now at this point here, okay, it's the actual solution to fx equals to 0. And we're looking at this equation, this bit being equal to 0 there. That's 5 over 2. Okay, and for this point here, we're looking for where the graph says, so we're looking for the point when x is equal to 0 on there, which would be minus 5 on this. Okay, 0, because you'd get minus 5, but of course it would be plus 5 on this one. Putting 5 into that, putting 0 into this function here, I'm just rubbing out. Putting 0 into this function here, I will get 5, but of course I'm taking the minus 5, but of course I'm taking the modulus of that, so I'm getting plus 5. Okay, that's it.